So I'll be talking about the EV battery and its current form and what future holds for the EV batteries. To start off with, it's very evident that how we are moving from fossil fuel to other form of technologies that are going to power our vehicles. The prime objective is to reduce the dependency on the fossil fuel. And when we started looking at alternatives of fossil fuel, batteries come as a very natural and a logical extension to be replaced uh, by fossil fuels, and how it can power the vehicles of any form factor, starting from cycles, two-wheelers, three-wheelers, up to cars and buses. But there is this history of the electric vehicles that, how it started off in Europe and America, but now how China and India are taking the front lead in the electrification of the vehicle in various segments, be it B2C, B2B, last mile electrification, and so on and so forth. When we talk about EVs, there are two modes how the electric vehicles are being powered or batteries are being charged. Okay, the primary mode, and we all are aware of this, is typical vehicle charging, and government is taking a lot of steps in setting up the charging infrastructure across the country. The very new and alternate source of power EVs is battery swapping, where the vehicle need not to be charged, but once the battery is drained, it can be taken to the nearest swapping station, and the drained battery can be taken out of the vehicle, and that can be replaced by the fully charged battery from the swap station. This is typically, if I have to take the metaphor or analogy, it's more of the, it's similar to how in few years back, gas cylinders were used to be refueled. From our households, we used to give the empty cylinders and we used to get the fully filled cylinders, and that's typically how battery swapping works. But be it charging, be it battery swapping, or be it advanced fuel cell technology that is coming in a very short span of time. The thing is, right now, the entire ecosystem of EV battery is lying around lithium ion batteries. Okay. Now, most of these EVs across worldwide, they are using lithium ion batteries, but these lithium ion batteries also have a number of limitations. Fortunately, scientists and engineers are exploring a number of ways to overcome these challenges that could actually help give the drive to convert our vehicles to electricity a boost. If I just have to give a brief of lithium-ion batteries, they were first marketed by Sony in early 90s, probably 91 and 92, and have come to be the most prevalent rechargeable battery in the vehicle, just as they are in mobile phone and our laptops. The reason of using lithium ion is they are more efficient, they have a longer lifetimes, sometimes between 5 to 10 years, about 3 times than that of our traditional lead acid batteries. Also, lithium ion batteries store more energy and are also much lighter, meaning a vehicle equipped with lithium ion battery uses less energy to move. These batteries generate energy by moving something called charged particle, like ions, backward and forward between two electrodes. Now, when the battery is charged, lithium ion pass from a metal oxide compound electrode to a graphite electrode. And when the battery is discharged to power the vehicle, the lithium ion go to the other way around, right? In order to make lithium ion batteries cheaper, the technology developers are looking at lithium iron phosphate batteries or LFP battery pack. In India, we have recently started using LFP battery pack in a few of the vehicles and form factors, which use different electrode elements. And this battery model is even much cheaper and safer than the widely used lithium nickel manganese oxide batteries, and also has a potential to power a car up to 250 miles or more with as little as 10 to 15 minutes of charge. See, the biggest challenge that was there with EV and it still persists is the range anxiety. okay, around the fully charged EVs. And this is also driving vehicle makers or manufacturer to develop battery which use a solid component that separate the electrode rather than a liquid one. Okay, but lithium batteries have a problem here. It's more of a relatively rare element on Earth compared with most minerals in common use. And as demand for batteries is going to increase, the price of lithium will also increase sharply. And this has prompted, a lot of geologists across the world to search for new sources of lithium worldwide. And often it comes with its own high cost. Okay, and for example, uh, if you look at the extraction of lithium from salt flat in Chile, it consumes less water, and which is in short supply there. At the same time, other components such as cobalt is also scarce compared to similar metals like iron or ores. So this is going to put a challenge in terms of, if we look at long-term supply of lithium ion for the battery. One solution may be to get more use out of what we already have, with more than close to 1 million cars which are sold worldwide in last couple of years. uh, a lot of scientists are studying how to recycle this lithium on a massive scale, and how it can be converted for further use for EVs as well as non-EV uses. Typically, in case of EV, battery life cycle is standing somewhere around 1200 to 1500 number of charge cycles. But even after that, the same battery can be used for so many different purposes, since it has a higher life cycle for up to 4000, 5000 charge cycles. That's where the massive shift is going to happen in the next 2 to 3 years, that how the existing batteries can be utilized in more than one ways apart from powering the EVs. Also, in future, it will be important to design batteries that can be easily disassembled and easily detachable, okay, to reuse the metal that they contain. Uh, there are also potential alternative to lithium that is being explored. For example, very recently we have started exploring something called sodium iron batteries. They are gathering a lot of interest from EV manufacturers across the world due to their lower cost. They work very similar to lithium ion batteries, but the problem is sodium is a bit heavier and store less energy. Now, somewhat further into the future are multivalent batteries, where the ion that moves between the electrodes has the greater charge than lithium, and so delivers more than one electron each to the circuit. And there are substation challenges for developers to overcome with these batteries, but they could potentially deliver even higher energy storage. uh, but this is more of a technical development in terms of EV batteries. One also has to look at the EV adoption in India when it comes to utility of electric vehicles across the segments. What we have witnessed, at least over the past few quarters, there has been a steady rise in the demand of electric vehicles in India. And this demand is being witnessed across the different segments, be it B2C two-wheeler segment, B2B, or last mile delivery segment that is also seeing a very high demand, or demands coming from three-wheelers, cars, as well as the buses under PLI scheme, which is launched by a lot of government agencies. Slowly and gradually, this is going to lead to a huge demand in EVs and in term and the demand of EV batteries. The another catalyst that is going to give a boost to demand of electric vehicles in coming years probably is the push of government given to battery swapping technology. Now I'll take a minute to explain how swapping works. Uh, at mass level, battery swapping stations are set up at a grid perspective across the city, and similar to how we get our vehicle refueled with petrol and diesel, the similar kind of stations or locations can be used to do the swap of the battery. the benefit given to this model is one need not to wait for 2 hours or 3 hours to charge their vehicle, or they need not to put their vehicle for a full night charge so as to be used in the morning. Uh, Contrary to that, they can actually swap the battery within a minute or two, and they can continue with their vehicle usage. That actually reduces the range anxiety that is there around electric vehicles, and that can actually facilitate the much required adoption of EV in our country. Recently, Finance Minister ma'am also mentioned the push about the battery swapping in their budget speech, and very recently, government is gonna come up with their own battery swapping policy to facilitate, the energy players who are going to provide battery as a service platform, where probably rather than purchasing a battery along with the vehicle, one can opt for a subscription based model, and he or she can purchase the vehicle without the battery, and then they can use the network of battery swapping station to power their vehicle. This has the potential to actually facilitate the demand by a great margin compared to battery fitted vehicles, simply because if you look at the cost component of an electric vehicle, 40 to 50% of the cost is of the battery that is being fitted in the vehicle. Typically, in Indian scenario, an electric vehicle is pricing somewhere between 80,000 to 1 lakh. Now, in that price band, 40 to 50% of the cost goes to the battery. So the scooter is just costing somewhere around 45 to 50,000, but rest of the cost is associated with the battery that it comes that comes with the vehicle. Now, if the vehicle is available without the battery, then one can actually consider procuring electric vehicle compared to the already expensive petrol vehicles which are available in the market, and they can start using battery as a service for their usage. That can actually reduce the running cost of the electric vehicle to as low as rupees 1 per kilometer, compared to rupees 3 to 4 per kilometer with petrol vehicle, that is given the petrol pricing of today's. Now, how it is going to shift in the demand of lithium ion battery is, for each of the vehicle. Right now what is happening is, with the battery fitted vehicle, you need to procure just one battery with each vehicle. With battery swapping, since it is going to give a huge flexibility to the user, that also means that the battery floating batteries which are going to the grid of battery swapping station is going to cost a bit more. Now, for each of the vehicle, one has to have close to 1.3 to 1.5 batteries to be used in the system so as to power the vehicle. But yes, it also has the potential to facilitate the kind of push government is going to give in order to have a greater adoption of the electric vehicles in the country across the form factor. Obviously it will start from two wheelers and three wheelers, and slowly it will move towards cars and buses and other form factors. That also going to push a lot of demand of lithium ion batteries. There has been a lot of talk about hydrogen fuel cell also very lately, and advanced cell program as well. Uh, how they are going to impact, the usage of lithium ion battery is, right now, the good thing is, a lot of startups and innovators are looking to explore a lot of different options to power vehicles, and be it hydrogen, be it aluminum air density batteries, which is being developed in Israel, and a lot of other options are gonna come into the market. But what holds the key is, the commercialization of these options and the kind of adoption it is going to take into the market. We have seen, in the case of CNG over the past 2 decades, that if I leave couple of cities like Delhi or to some extent Gujarat, CNG was promoted as a clean fuel option, as a cheap alternative to the fuel vehicles, to the fossil fuel vehicles. But somehow it was not able to create the kind of impact it was supposed to be, simply because the adoption and commercialization were not up to the mark. Still, we see that at any CNG station, we see a lot of queues, the long queues of the vehicle that are being waited, and that is actually discouraging a lot of users to adopt for CNG, in spite of the fact that it is relatively cheaper these days. So again, all the alternative technologies which are under development, the key is not to have a proper technology, but to have the right commercialization and how we are going to deliver it to the end user. That holds the key for a success. And in that aspect and in that regard, I feel that EV electric vehicles, powered by lithium and batteries, they have still achieved quite a first mover advantage, and at least for the next 10 to 15 years it is going to be there in the market, and they are going to dominate as a very strong alternative to fossil fuel vehicles. uh, when we talk about the disposing of EV batteries, as I mentioned a couple of minutes earlier, that these batteries, which have a charge cycle of generally 1200 to 1500, in the case of electric vehicle usage, the same battery can be used for alternative applications or use case, such as powering the grid or domestic usage, where their charge cycle can last up to 4000 to 5000 charge cycles. The 1200 to 1500 charge cycle in EV, that roughly translates into 80,000 to 90,000 kilometers of the electric vehicle that is being done. That again, in the case of two-wheeler, this translates into the life cycle of 3 to 4 years of the vehicle. At the same time, yes, it's going to be a challenge on how the disposing of lithium-ion battery is going to be shaped up. Or right now, industry has not achieved or reached to that point or that cycle where they have to look at it from a serious concern. But yes, efforts have already been made from the government as well as from the manufacturers and private players, so as to how efficiently it can be disposed of without hampering the environment. Uh, because yes, it is touted as a clean energy, and a very efficient way of disposing it off will actually make it true to its prime objective of moving towards a greener and better future.